Hey guys, in this video, I'm going to be giving you a pretty good review on what's going to be on the final. This video shouldn't be very long because I'm going to get right to the point. We're going to start with exponential functions. Remember, for it to be an exponential function, the variable x is now going to be in the exponent. So if we have the function g of x is equal to 3 times 2 to the power of x, this would be considered an exponential function. The main thing that I really want to point out is remember, the number that does not have a variable attached to it, that is going to be your y-intercept. That's going to be your y-intercept. If we look at a graph of an exponential function, remember the graph is going to it's going to either rise really quick in one direction or it's going to fall really quick in a direction. That is going to be an exponential function. Moving on here, we talking about quadratic functions here. Now, a quadratic function will be in the form y equals ax squared plus bx plus c. And remember, c is going to be the only number here that's not going to have the variable x attached to it. So whatever number is in the c spot, the number that does not have a variable attached to it is going to be your y-intercept. If we look at a quadratic function on a graph, you can point out different key attributes of that graph. Let's look right here. These 2 points right here I just put in blue. These are your roots, your solutions, your zeros, your x-intercepts. They're going to be your x-intercepts. Remember that if I right down the middle, split it right down the middle, the number that I pass on that x-axis, in this case, is going to be a -3. My axis of symmetry will be x is equal to a -3. Remember, this is the axis of symmetry. It's going to be the only thing that is going to be a equation. Another important attribute that you can find on a quadratic graph is going to be the vertex. The very tip of that graph is the very tip of that graph. And the vertex, you put your pencil on that point and drag it to the x-axis. I'm going to be at a -3. Sorry, this right here also should be a -3. I'm going to be at a -3. Put my pencil on the point and drag it to the y-axis, and at a -2. This will be considered my vertex. You can't really see our y-intercept, but if this graph continues to get wider as it continues to go up, at some point it would cross that y-axis. We just can't see it here. We can't see it here. Let's continue here and let's think about functions. Remember that if the x is repeated in a function, then it can't be a function, and I will graph it and explain it to you. But if you have the question, which table represents y as a function of x? Well, what is this essentially asking? It's asking which, I'm not going to say one, which table is a function. If it's asking which table represents y as a function of x, it's just asking you which one is a function. So if I look at my 3 tables here, I want to look at my x values here. That's not going to be negative. I meant to put a circle. I just want to look at these values right here. Just your x. It doesn't matter about your y's. Your y's can repeat all day long, but you want to look at your x's. Let's look at this first table here. Do I have any x's that's repeating? I don't. If the x's don't repeat, it's a function. In this table right here, I have a -1 and a -1. My x's repeat, not a function. Let's look at this last one here. I have a 5 and a 5. It repeats, not a function. Let me show something here on a graph, just to tell you why. Remember, if we have a linear function, our graph, if we plot these points, our graph should make a straight line. It shouldn't go all over the place. It shouldn't make a squiggly line. It should make a straight line. Let's take a look at it here. I'm not going to be able to graph everything. But let's look at -1, 3. I'm going to plot that point. I'm going to go over to -1 and up to 3. Point there. 2, 4. I'm going to put a point at positive. I'm going to go over to 2 on the x and up to 4 on my y-axis. I'm going to put a point there. -1 and 6. I'm going to go over to -1 and I'm going to go all the way up to 6. You can't see 6 here. Make 2 more points here. I'm going to go all the way up to 6. -1 and 6. I'm going to put a point here. I can stop there because if I drew a line for this graph, I would make some type of little L here, a little acute angle here. And we know that for it to be a linear function, it must make a straight line. So if I change this particular number right here, let's say I make it a +4. I make it a +4. If I go over here to +4 and up to 6, I would be on this particular graph. And now this would now be considered a function. Another thing that you want to be sure that you understand is going to be Mr. Slope Man. Remember, if I have a coordinate plane, I'm just going to draw a little graph here. X-axis, y-axis here. And if I have this blue graph, if my graph is going in this direction, this means that I'm going to have a positive slope. That's what this means over here on Mr. Slopeman. If my graph looks like this right here, like what I just drew, I'm going to have a positive slope. If it looks like this orange line going in the opposite way, it's going to look like this graph right here. That means that my slope is going to be negative. My slope is going to be negative. If I have a vertical line and it's going through the x-axis, that means that my slope is going to be undefined. And not only is my slope going to be undefined, my equation for a vertical line down through the x-axis would be x equals, because it's going to go through a number on the x-axis. And if I have a horizontal line that's going directly through my y-axis, my slope is going to be equal to 0. That's what these mean right here. It's going to be equal to 0. Back on this undefined slope, that's what this U means right here underneath this line. It means there's going to be an undefined slope. But if I have a horizontal line and it's going across my y-axis, this equation would be y equals. All right, how do we find slope in class? Well, we have two different ways that you can find slope. You can use box method or you can use stat in the calculator. I'm going to write those steps down. For box method, remember, if you want to take your 2 points and stack them on top of each other. Take 2 points and stack on top of each other. Step 2, you're going to subtract top to bottom. Step 3, you are going to divide right to left. That will give you your slope. I'm going to do these steps right now. So step 1 says take my 2 points. I have 1 point, 10, 17, another point, 7, 8. I'm going to stack them on top of each other. I'm not going to take my first point and do 10 and 17, stack them like this. No, I'm going to take my first point and I'm just going to write down exactly what I see. 10, 17, 10, 17. And then I'm going to take my other point, 7, 8, and I'm going to put it right underneath my first point. I should have put right here, I'm sorry. Draw a box. Draw box around. Should have added that into my steps, I'm sorry. Because you're going to want to draw a box around these 2 points right here. Draw a box. And then step 2 says subtract from top to bottom. I'm just going to put these little subtraction symbols to remind me that I'm going to be subtracting from top to bottom. So I'm going to subtract 10 minus 7. So 10 minus 7 and also 17 minus 8. 17 minus 8. So 10 minus 7 will give me 3 and 17 minus 8 will give me 9. And my last step here is to divide from right to left. That means that the number on my right side, in this case is 9, is going to be on top. I'm going to divide 9 divided by 3. So 9 divided by 3. 9 divided by 3, and that will give me a slope of 3. Because if you just divide 9 divided by 3, it will give you 3. That means that my slope of these 2 points would be 3. Now, you have another way that you can solve these. If you have the calculator, you can go to Stat. You want to hit Edit. Enter for Edit. You want to hit Enter for Edit. And then in L1, you're going to put your X values. In L2, you're going to put your Y values. And so you could still do the exact same thing as far as stacking your points on top of each other. 10, 17, 7, 8. But instead of making a box this time, just make your little T-chart. Now you have a table of X and Y values. You're going to put your X values in L1, your Y values in L2. You're going to hit Stat again. You're going to go arrow over to Calc. And the option that you're going to hit is going to be 4 because you're dealing with slope. And we know that when we find slope, we're dealing with a linear function. So it's going to be for line reg. It's going to be for line reg. I should say something like that. And then you're going to hit Enter, and then it should give you an A and a B. And remember, in the calculator, A is just another way of saying slope. It's the variable M. And Y equals MX plus B. M is your slope. In the calculator, it's going to say Y equals AX plus B. So A would still be your slope. So in the calculator, A would be your slope. And let's look at it right now. So if I bring up my calculator here and I go to stat, I go to edit, I am going to delete out everything that I have here so far. And in L1, I'm going to put 10 and 7 because those are my X values. 10 and 7, I'm going to go over to L2 and I'm going to put my Y values 17 and 8 and I'm going to hit stat and I'm going to go over to calc. I'm going to hit option 4 for line reg, hit enter, and you see that my slope A is going to be equal to 3, and that's the exact same slope I found when we did box method. Another thing that's going to be on the final is going to be a question about systems of equations. Remember that when you have a systems of equations, you're going to have two different equations, and you want to actually read the problem thoroughly to see the important things and to see the stuff that may not be too important. Let's read this one together. A television weighs 50 pounds and a microwave weighs 30 pounds. A TV occupies 4 cubic feet and microwave occupies 3 cubic feet. A truck is carrying 1,500 pounds of cargo that occupies 138 cubic feet of space. Which system of equations can be used to find the total number of televisions T? So we know that televisions, we're going to use the variable T, and microwaves, we're going to use the variable M. So if you remember this example that I said, if you have one book and you add it to another book, can that equal a car? It sounds ridiculous, I know. No, it can't. One book plus one book, it must give me two books. But the thing I want you to realize here is that a book plus a book must give me a book. You must keep the alike things together. The alike things together. So let's look back at our problem here. If we have two different equations, we're going to have two main things that we're going to be looking for in these equations. Let's read this first sentence again. A television weighs 50 pounds and a microwave weighs 30 pounds. It looks like that we're going to be talking about pounds here, weight. So remember, pound plus pound, pound plus pound must equal pound. Pound plus pound must equal pound. A TV occupies 4 cubic feet space and microwave occupies 3 cubic feet. Okay, so now we're talking about space now. We're talking about cubic feet of space. So space plus space, it must give me space. Space plus space can't give me pound. Can't give me pound. So let's look at this. Let's look at some of these answer choices here. Okay, let's look at answer choice A. We have 50T plus 30M equals 138. Well, we know that T is for television and M is for microwaves. So we know that a television weighs 50 pounds. That checks out. So we're talking about pounds here. So pound plus pound must equal pound. But in this case, pound plus pound is giving us space because 138 is associated with cubic feet of space. So A cannot be the right answer because we must keep these alike things together. So we know that A is not going to be right. Let's look at B here. 50T plus 4M equals 1,500. This just looks off here. 50 pounds is associated with TV. That checks out. But if we're talking about 50 pounds of TV, we must be adding it to pounds. And we're adding it what looks like to be to space because we're adding it to 4M, which is saying 4 cubic feet of microwave, and that doesn't check out because the amount of space that a microwave takes up is 3 cubic feet. This whole equation right here, it just doesn't make sense. So we know that B is not going to be the right answer. Let's look at C here. Let's look at C. We can pretty much already tell that C is not going to be right simply because the first in the first equation here, you see 50. It doesn't even have a variable attached to it. We know right there that C cannot be the right answer because every number here, it should have some type of variable attached to it. Now let's look at D. We know that we've exited out A, B, and C, so clearly D is probably going to be our correct answer. But we still want to be sure that we have the right answer, so let's make sure that everything checks out. 50T plus 30M. 50 is associated with television. That checks out. 30 is associated with microwave. That checks out. We're talking about pounds here, so pound plus pound must equal pound. And does it equal 1,500? 1,500 is associated with pounds. The first equation checks out. Let's look at this next one. Remember, if we said pound plus pound must equal pound, that second equation, space plus space must equal space. So we have 4T T is for television. TV occupies 4 cubic feet. That checks out. M is for microwave, and microwave occupies 3 cubic feet. That checks out. Space plus space must equal space. In this case, 138 is associated with cubic feet of space. So the second equation checks out as well. Also, you may see something dealing with linear inequalities. Now, the important thing that you have to know about a linear inequality, if you have to graph a linear inequality and it gives you an inequality in standard form, the first thing you have to do is cross method. Make your cross. Remember, change x. The number in front of that x, if it's negative, we're going to make it positive. Keep your answer. We're going to keep 20, and you're going to keep your y. In this case, we have a positive 2, so I'm going to put 2 on both bottoms. You're going to be dividing from top to bottom. 4 divided by 2 will give you 2. 20 divided by 2 will give you 10. 20 divided by 2 will give you 10. Remember, you're going to put x behind your slope, y. You're going to keep this symbol, whatever symbol you had in your original problem. You're going to keep that symbol. The only time that you would not keep that symbol is if you divide by a negative number. But if you do not divide by a negative number, keep that exact symbol. So we have y is less than 2x plus 10. Now, if I wanted to graph this, the main thing you need to pay attention to is going to be your inequality symbol here. Remember, if I'm just going to make my little chart here. I'm going to make my little chart. You might want to jot this down if you need it so you can remember it. The inequality symbol will tell you if you need to shade above, shade below, use dashes, or use a solid line whenever you are graphing. I'm going to explain it right now. And we're going to be shading above with these. Okay. So if you have the symbol less than or equal to, you are going to be shading below that graph. So in this case, we have a less than. So we know that we're going to be shading. We have a less than. So we're going to be shading below. We're going to be shading below the graph. And then if you have a less than or greater than without the or equal to, we know that our line that we're going to use is going to be dashes. So we know for this case, we will be using dashes to draw our line, to connect our points. If you have greater than or greater than or equal to, you're going to be shading above the graph. This is how you read this chart here. You're going to be shading above. And if you have less than or equal to or greater than or equal to, so if that or equal to sign is underneath, that's how you know that you're going to be using a solid line to connect your points on your graph. On your final, you may see an equivalency type of question. And if you see a question that says which expression is equivalent to 3 times the square root of 5, how you will solve this question is, well, the first thing you would have to do is you would have to know what 3 times the square root of 5 is. You will go to your calculator. This is basically just saying 3 times the square root of 5. It just didn't write it didn't write any parentheses or the actual multiplication symbol, but this is what this is basically saying: 3 times the square root of 5. So I want to know what that is. I'm just going to type it in my calculator here. 3. I'm going to hit second and the x squared button to bring up my radical symbol. I'm going to type it exactly as I see it, and I'm going to hit enter. And I'm going to get this number right here, 6.708203. You don't have to write the entire thing. Remember, equivalency means equal to. This is going to mean, move this real quick, sorry. This is going to mean equal to. So you want to look at your answer choices here, and you want to actually solve these answer choices to see if you actually get a number that equals this number that we just found for 3 times the square root of 5. So I'm going to take the square root of 85, and I'm going to just see what it gives me. It gives me 9.219. Well, that doesn't equal 6.7, so that's not going to be the right answer. I'm going to go to B. 3 times the square root of 7. Enter. 7.937. That doesn't equal 6.7. I'm going to do the square root of 45. 6.708203. It looks like we have a winner. 6.708203. Once you see that those numbers match up, you know that that these two expressions are going to be equivalent to each other. The last thing you may see on your final exam is going to be a question on domain and range. Remember, when we're talking about domain and range, you are going to have your domain, which is going to be associated with the x-axis, and then your range is going to be associated, sorry, I did that wrong. Then your range is going to be associated with your y-axis. With your y-axis, it's going to be your x-axis, it's going to be your y-axis. I drew a graph over here to give you an example here. If I asked you to find the domain of this graph right here, remember your domain, how you're going to do that is, since you're dealing with this, because you're dealing with the x-axis, you're going to be dealing with this horizontal line. We're going to be basically measuring this graph from left to right, and you want to start with your negative. You want to start on the negative side of the x-axis, so you want to scan left to right. Scan left to right. I'm going to explain exactly what I mean here. If I want to find my domain, I'm going to start on this side of my x-axis, and I'm just going to drag my pencil until I get to a point associated with that x-axis. I'm going to stop right here because the point that I see associated is going to be right here. The graph starts right here. I'm going to be measuring the furthest to the left to the furthest to the right on the x-axis. So the number that I'm going to be at is going to be a -2. So I'm going to write my answer just like this. -2. I have a closed endpoint right here. This means, since it's a solid dot, it's a closed endpoint, and because of that closed endpoint, I am going to use the symbol less than or equal to. Less than or equal to, I'm dealing with my domain, so I'm going to use the variable x, and now I'm going to continue on measuring until I get to the furthest part on my graph on the x-axis. Would I stop at this? Would I stop at the actual graph right here? No, I wouldn't, because I want to get the furthest part on the graph that's associated with the x-axis, and that's going to be right here at a +4. At a +4. So I'm going to have a +4 right here, but right here, I don't have a closed endpoint. I have an open endpoint. I have an open endpoint. So that means that this point is not included. This point is not included. So the open endpoint means you want to use the symbol less than. Less than. So -2 is less than or equal to x. Less than 4 would be our domain for this particular graph. For our range here, you are going to scan top to bottom because you want to start with the negative numbers. So I like to say scan, I'm sorry, not top to bottom, bottom to top, excuse me. Bottom to top, because you want to start with your negative numbers. You want to, we're gonna be measuring the graph, the pretty much the height of the graph now. So you're gonna start here at the bottom, and you're just gonna make your way up this y-axis, just dragging your pencil until you get to a point associated with that graph, and that's going to be right here at -1. -1. So when I'm writing my range, I'm going to do -1. I have a open endpoint. So open endpoint means that you're going to be using the less than symbol. I'm going to put less than. I'm dealing with range, so my variable is going to be y, and I'm going to continue up until I get to the to the highest point on my graph. So would I stop right here on my graph? No, I will continue up until I get to the highest point, which looks like it's going to be at a +3 here. It's going to be at a +3. So I have a +3, have a closed endpoint. So I'm going to use the symbol less than or equal to. Remember, if you have a closed endpoint, you're going to use less than or equal to. Open endpoint, just less than. Just, you do not need the or equal to, because the point would not be included. It would not be included in the range of the graph there.